Hello and welcome to lecture 14. So you just saw in the last lecture we were talking about progressively developing the queue of a case study, a case design study. In this one, we're going to be talking about inheritance, right? So we've been throughout this course kind of have the same mentality of we're going to do a little bit of Scala, a little bit of Chisel, a little bit of design, apply it, put it all together. We just put it all together at that case design study, and now we're going to learn a little bit more Scala to kind of be a little more powerful. So we've been using inheritance, and we haven't really talked about it properly, including even that last lecture. Let's talk about it more intentionally and also how we can use it for profit, so to speak. Let's talk about inheritance originally in Scala, then of course how to use it in Chisel. There's some details, right? Things like type parameterization. Remember we talked about in the last lecture about that queue. Arbitrary bit width for the data type, but it was still a uint. What is one arbitrary type? That'd be type parameterization. And then I'm also going to give some more advice about the project. As a reminder, right, we are expecting those proposals in 6 days, question mark? I think so. Yeah, they'll double check the or 13 days. Okay, 13 days. Lucky you. But still, think about it, right? Don't be afraid to come talk to me in the office about your ideas. So I guess a week from Monday. So 13 days. Um, get those going. Okay. So fire up the old notebook. Good to go. So why use object-oriented inheritance, right? If you remember the very first lecture of this course, or even the first couple lectures, kept saying Scala is this great language. We use all of its powers and make hard design great, including object-oriented programming and functional programming. You've seen functional programming, right? There's a way where sometimes if we use it correctly, we can get these commonly used patterns captured concisely and correctly, and it's very productive and very clear and easy to read if used correctly. Object-oriented we've also been using, and we use it once again also hopefully more intentionally, right? Now the whole idea is of course reuse, right? We want to make these things that are easy to reuse. And that's what inheritance comes in. Object-oriented is about encapsulation. Inheritance is about reuse. Or how do we make pieces that are the right size and shape so we can kind of use them where we want? Um, so when you think about inheritance, the goal is uh, identifying the key similarities and differences, right? So in other words, I have components that are not exactly the same. If they are exactly the same, of course, I can just instantiate multiple times. But if they're similar but not quite the same, okay, well, how do I have a way to reuse the code between both those components in a way for things that are the same, I can use the same code. And for things that are different, how can I, you know, expose a difference, right? So that's what we're dealing with. Now, we've seen throughout this course, Scala is a very rich language. It will not have one feature when one will suffice. It'll give you 5 features, right? And so you'll see over the course of this lecture, of course, to be in 2 parts, there's quite a few different object-oriented mechanisms for inheritance in Scala. It's a little bit daunting. It's okay. Take a deep breath. I have a summary slide. We'll get through it. Okay. So what kind of inheritance is there? Well, first off, there's the regular class inheritance, which we've been doing and not even realizing we were doing it, which is simply we have a class, in this case, let's say parent, and then we make a new class, let's say child, which simply extends, i.e. inherits from parent. So that's not super crazy, right? We've seen this in other languages. In other words, this class is going to behave exactly the same as its parent class unless we specifically override something, right? And if we override something, meaning we want the child implementation to win, it'll behave differently. But if we don't do that, it should behave the same. So let's go ahead and put this together. So let's say, for example, we have Kate, who's in this instance of parent, right? You know, they have a name, they have the ability to greet. So yeah, we run this and, you know, we want to greet Kate. We'll say, hello, Kate, right? Um, Now for the child class, uh, if we override the phrase for greeting with hola, right? Now when we greet Pablo, the child, we get hola Pablo, right? But the key thing is like, notice how this child code, we overrode the value of phrase. We didn't change greet. So greet is actually coming from the parent class. Greet assembles the string by putting in phrase, and phrase came from me, right? Rather than from there. Now let's see a few scenarios. Like what if I, for example, didn't override anything? Well, then the child's going to behave just like the parent, right? Um, can you put things in children that aren't a parent at all? Definitely. You know, That's fine. Um, Now what happens if I forget the override keyword? It's going to tell you, whoa, 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 you're overriding something, right? So you need to be explicit about, you know what, this is something that exists in the parent, and I'm intentionally overriding it. Cool. But this is, like you probably see in their languages for object-oriented inheritance, this is nothing too wild, but there's a couple of details, right? Number one, uh, when you do want to override things, i.e., not do what the parent provides, you have to use the override keyword. Number two, you can only inherit from a single class, right? So some languages have multiple inheritance. You can have multiple parents, not Scala. We'll see a way to get a similar functionality via another mechanism later in this lecture, but for the regular class inheritance, no, that can only be a single thing. Cool. You may have noticed, for example, that when we declare modules in Chisel, we say extends module, right? That's we're inheriting from module from the Chisel library. Yes, that's a great language question that I answer with an 80% confidence interval. So the question is restriction of single parent inheritance, is that something from all JVM languages or a more broad thing? Um, so the more broad thing is there's something called, I believe, called a diamond problem, where basically if you have multiple parents you inherit from, you can kind of get yourself in this conundrum of where it becomes ambiguous of like how to like know where something comes from. And Swift Plus has this problem as well. However, they have their way of solving it, and I forgive me for not remembering that solution C++ has. I believe, speaking opinionistically rather than authoritatively, that the modern philosophy of language design is to encourage single inheritance because of that diamond problem. So I don't know if this is always a JVM specific problem. I don't think JVM makes this easy. I agree that'd probably be tricky for sure. But I also imagine people making new languages intentionally making this choice. Like, for example, I don't know if you probably know Rust. Does Rust let you do multiple inheritance or no? Because like so Rust is the more modern language. The question is they had a choice, right? And what choice did they make? And they decided, what, this is more pain than it's worth. Like I said, the issue is when you have multiple inheritance, it's kind of what comes from where, right? And you're going to see a way to approximate multiple inheritance, something called traits later on or mix-ins, and that suffices for a lot of cases. And so you'll see that later in this lecture. But yeah, these are kind of these like language design questions about how you design a language. And yeah, as I believe speaking, my impression of how the Scala people chose this was not only does Java require a single inheritance, but they also, and they're kind of constrained by JVM, but also I think that's kind of the belief that's better for now. But yeah, ask the professor questions he should know, does not know. Good, good, good task. Um, so that was one kind of inheritance. Check. I told you people once. What's the next one? Abstract class inheritance. So it's really similar, right? Uh, what's the difference? The difference is the original parent class now just keyword abstract in front. And what's different about that is uh, because it's an abstract class, this cannot be instantiated, right? If I want to say, hey, give me, oops, a new parent, named, something else, I can't instantiate an abstract class, right? So tell you can't do that. So abstract classes are made to be inherited. And so the advantage of making this abstract class as opposed to just using any plain old class is we're not required to fully populate it, right? It's not going to be fully self-standing because it's never going to be instantiated. So because it's never going to be fully self-standing, um, we can kind of take some shortcuts. For example, like here, notice how I say there's going to be something called phrase that's going to be a string, but I don't give it a value. And it's a val, so I can't like change this value later on, right? It's a little bit, surprising, right? That seems a little peculiar, what you know, but the reason why it's okay is you can see the classes that extend it, they assign something to it. And they actually don't need the override keyword because it's an abstract class, right? Like the abstract class is meant to be like overridden. Yes, good question. If I don't set phrase something, what happens? Let's find out. I need to set it, right? That's kind of the point. So one way to kind of think of an abstract class is almost like you're sketching out like the shape of something needs to be. And point of view of interfacing with other modules, right, it knows, okay, you need to have these fields, but the actual bodies of those fields are required to be provided by the child, right? Now, just because it's abstract doesn't mean you can't actually have some things implemented. Like we chose to have greet implemented there, right? Um, and yeah, we can see, yeah, we can have, in English versus in Spanish, no problem, right? And so, yeah, abstract classes must be inherited. And, from a mechanistic point of view, okay, well, if I didn't have abstract classes and only had class, you can still write great code. You can still write great code. By adding abstract class, you just case for trying to get, more closely lining up the abstractions, what's available. You can have this abstract class, which is, unimplementable, sorry, uninstantiatable, and then you can implement it with these children, right? As I said in the last slide, right? If you're really excited about multiple inheritance, there's this thing called a trait we'll be covering later in this lecture. Um, so already we have class and abstract class, and then to see how you might build a hierarchy of things with inheritance, let's take a look actually at Scala itself. So we've been hyping up the Scala collections. Here are the Scala collections. So this is their tree showing what inherits from what. So you notice you trace this tree. Uh, it is single parent, right? Each of these things has only one parent. Um, and so what is a collection? Well, at its core, it's a traversable. I can't tell you the difference between traversal versus iterable. I don't know that nuance, but you can see there's a difference in terms of some of those concepts when they made these schemes out. In this particular arrangement, all the blue boxes are abstract. So even though we say seek, it actually gets turned into, we actually look at the code, it turns into like a list or a vector, right? Typically, right? Um, but the key thing is, yeah, so a collection is iterable, right? Okay, yeah, that makes sense. I have some n things. I should be able to iterate through them. And then you can see, okay, well, of those n things, what kind of properties might they have? If you have this notion of a set where they're somehow all unique and they can't be redundant, that's one notion. If you have a notion of them being somehow numerically indexed contiguously from 0 to n, that's a seek or a sequence. If I have a notion of them being indexable with some sort of arbitrary key type, that's a map, right? Like a hash table, hash map kind of thing. Um, you can kind of see how they kind of made this hierarchy very deliberately, kind of breaking things up. Okay, well, I have a set. Now, a set is a property having a set property. I can have a sorted set. I can have a set using a bitmap underneath a bit set. Even with a seek, right? You can see seek has the idea of numeric indices, but how is it implemented? Is it done uh, with a kind of a contiguous array like thing, like a vector, or is it done more of a linked list kind of thing, right? You can see these kind of different nuances. And so I'm pulling this up as an example. You can see how as you start building all this stuff up, you can realize that things are more similar than are different, right? The alternative would be rather than having this tree, if you had no inheritance, you would have, you know, 1, 2, 3, 4, 5, 6. I believe I count 14 dark gray boxes. So with 14 dark gray boxes, I could have 14 classes that are just my collections available to me. I could scroll through the developer, pick which one I want. And then, with very deliberate effort from the people implementing those classes, they could have very similar seeming method names. Okay, so how do I get the dot size? How do I do dot empty? Or I could actually make them all inherited. And it's like guaranteed to be the same API, right? So it kind of comes together. And you can imagine how some of the functionality can be reused, right? Like perhaps if you have the functionality to do iteration, the same iteration functionality can also help you do things like full empty, right? And so you can see it kind of comes together. So object oriented is really powerful. Uh, this, diagram, of course, I got from the Scala documentation. You can see here is showing the abstract classes. Here is what the things in there. Here's the mutable version. Here's more about what the legends actually mean. Cool. Questions? So yeah, so we've already seen regular class inheritance, abstract class inheritance. Unfortunately, that's not all. Okay, what else do we have? Uh, Before we do that, let's talk about how do we use these in Chisel. Um, so we've been trying to get reuse, right? So number one type of reuse, any kind of reuse you can, right? Stop writing new code, write code we can use multiple places to save writing new code. So number one, these parameterized generators, right? We want to have the ability to kind of give some parameters and to spit out what we need. Um, and the goal of having it be a generator rather than a single design. Hopefully, it's sufficiently flexible to be used in more places, right? And um, we've seen that in a few different ways, right? Typically, we write a module. We actually saw in one of the prior homeworks we can even have code outside of a module to have a function body by itself, right? Um, we've also had these composable, customizable bundles where we've decided, we can go ahead and encapsulate our functionality in certain ways with bundles. We can extend bundles. We can have optional fields in bundles. Then what today is, of course, is how can we get reuse via inheritance, right? How can we have similar functionality, but then provide, these modules look like maybe distinct modules that actually share a lot of code, right? Um, and so, yeah, it's a design decision, right? When you are implementing this as a library generator, you build this library, you may decide, okay, I want to provide this family of functionality. Is that going to be a single generator which has more parameters, or are those going to be different classes of peers generators, but actually in behind the scenes share code somehow? And I can share code directly, or I can share code via inheritance, right? And note that we've been using inheritance without even talking about it, right? Things like extend module, when you write a module, I told you that was boilerplate. Well, now you know what that means. It's actually extending module, a certain class inside a chisel, right? Same thing with extend bundle. When you make a bundle, it's also a certain class inside chisel. So now when you see modules, like it's less, you know, boilerplate than before, right? Um, it extends module, right? Like we just talked about. So uh, how about a simple example? Let's make a generator that is an abstract class, meaning I cannot directly instantiate this. Now, what is the pattern we're capturing? We're going to say it's a unary operator. In other words, it takes in one input, produces one output, and that input's going to have a certain width. Okay, so whatever that operation is, it takes in a uint, it makes a uint come out the other end. Our IO, of course, is going to be, input coming in, output going out of the width. And then we simply apply this operation there. So notice how it's an abstract class. We don't even say what op is going to be. Now, if I want to actually implement this, I can now say, hey, I want to pass through module. So I'm going to extend this, abstract class. And notice how if the abstract class has, parameters, you got to give it those parameters now. In this case, we're kind of passing through our own parameter from here to here. Okay. But then for pass-through operation, we will not change the module. So we're going to implement op as just x. Given x, return x. Alternatively, we had a negation module. We could do not x, right? And so what's kind of cool about this is if you, appreciate the reuse here, to write another unary op is as simple as doing this, right? So I can just write this Verilog, of course. We've seen this before all quarter. Sure, there it is, right? But now if I change from pass-through mod to neg mod, right? So really easy to kind of make this stuff up that way. Yeah, go ahead. Yes. What's a good question? Okay, so the question is, if I want to do object-oriented inheritance with chisel, here I'm reusing the IO. If I want each child to change the IO, what happens? Um, that's a good question. So IO is a little special in chisel. You'll notice that it's not just the name IO as a convention. There's also this IO code here, which is calling into an object IO to do some things behind the scenes. Um, I'm not sure exactly if there's a requirement about that, but I will tell you that in addition to module, there's some other variations that will help you in that quest you have. So raw module, for example, amongst other things, doesn't have the default clock and reset. So that may help you. There's also a multi-IO module. I may get the name wrong. That might be it. Uh, if I help line, what do we got? Do we have a? There's something that looks like sounds like multi-IO. Maybe. Oh, what is it? Oh, multi-IO module like this. There's a way to do multiple IOs. So for reasons of inheritance, there is a way to define IO blocks in multiple places, and you kind of keep adding them all together in aggregate. But you have to forgive me for a lecture not remembering the exact syntax. Yes, go ahead. But the question was, what happens if I try to override it? Let's just try it right now. Uh, Students suggested this was impossible. Let's see what happens if I try it. So of course that didn't work. Now if I try override, it might still not work. In this case, it worked in question mark, but like I believe the concern just might break in practice. Like I said, I was a little special for the way Chisel handles it. Yeah, here we go. Uh, Heaven knows what this freaking exception is, right? So, yeah, this is the worst kind of thing that you can trigger because this is not a compile time issue. This is a chisel whilst running issue, right? And it has its own internal stuff to try and make sure it doesn't emit bad Verilog, which is good. But me as a user, I'm like, ooh, right? And like I said, the weirdness here is, yeah, as observed, overriding IO doesn't work great. And so, yeah, I think between either a raw module or a multi-IO module might be a better way to kind of do that situation. Good questions. So let's try and build something. And I'm trying to look at the time. And you know what? I think I'm gonna do this better on Thursday. So we'll end it there. And I'll see